Lesson 4.1, Graphing Linear Equations. All right, so our goal is to understand the relationship between what we call linear equations and their visual graphs. All right, and so I know this is a new topic for us, so let's start taking a look at an example. So here's an example of where we might see the kind of math that we're about to tackle. Now, don't copy this particular part down, but let's say you're in your science class and you're doing a lab on the elasticity of a spring. So what we're doing here is we're comparing the weight hanging from the spring versus how far it stretches. And let's say in this particular case, we knew the dynamics of this spring, that it followed this particular pattern, that the length of the spring, let's say in inches, always turned out to be determined by the weight hanging from it, let's say in pounds. And so if you take the weight and you multiply that by 2 and then add 8 to it, that would give you the length of a spring. And so what we could do is we could fill out a data table like this one. And so this is the idea of using what we call linear equation to determine data. So in this case, what we would find out here is, let's say, let's get my pen. Let's say we plugged in 0. And if you do the mental math here, 2 times a weight of 0 would be 0, plus 8 would be 8. And so that means that this particular picture right here starts off with an 8-inch spring with no weight hanging from it. And then we could start plugging these pieces in. And so notice what's going on here. What we're doing is we're basically creating what we call a function, or a function machine, where one of the numbers is our input. The math that happens slowly gets churned out, and it spits out a particular output number. And so all we have to do is consider these numbers our inputs, which give us then our outputs. So if I put in 1, 2 times 1 is 2, plus 8 spits out an output of 10 inches. If I do the next one, weight of 2, well, 2 times 2 is 4 for the input, plus 8, which is 12, so the output is 12. And if we kept going, we would see a pattern emerge. This would be 14, 16, 18, 20, so on and so forth. So this is the idea of pulling data from what we call a linear equation or a function. Now let's take this one step further. A lot of times in science that this data helps, but it helps to look at it visually. So if I took that same set of data, but then graphed it as if these were coordinates, so like the coordinate 0, 8, where what we do is we treat this side, the input, as our x-coordinate, the other side, our output, is the y-coordinate, well then we can just treat these as coordinate pairs, 0, 8, 1, 10, and so on and so forth, and what we get is a graph that looks like this. And so this is our goal today, is to be able to go from some equation which has an input and an output, create a table of data from it, and then by graphing that data, getting the visual representation of that original equation. All right, so this animation that you're looking at right here is a way to think about linear equations, or sometimes we call them functions. That this is what some math teachers refer to as a way to think about this as an actual machine, something that you dump something in and it churns out a particular product. And so the idea behind what we're doing today with linear equations is basically you want to think of that equation as a machine. And all that machine does is it has a particular function that every time you put in a number, it does the same thing to that number and then spits out a particular output. Okay, so for example, if I were to drag in the 1, goes in, the machine does very particular things to it, and in this case, it output a 1. All right, now, if I drag in a 2, it's a different number, but what the machine does will be the same as before. Now, in this case, what happened to 2 is it became a 0. And so something's going on there mathematically within the machine that is taking these input numbers and then spitting out these particular output numbers. So let's try 3. Pop it in, machine does its thing, spits out a -1. Pop in a 4, we get a -2. Now, because this machine's doing a very particular thing every single time, we should start to see a pattern here. Okay, and we'll talk more about how to figure out this pattern in subsequent lessons. But for now, all we need to know is that this idea of a function machine is the same thing as what we're doing with linear equations. The idea of taking a number and inputting it and then getting a particular output number on the other side. Now, in this case, we might as well complete the pattern. Hopefully you see it, that notice as we go 1, 2, 3, 4, 5, 6, 7 with the input numbers, our output is 1, 0, -1, -2. So think about what the next one would be. Okay, in this case it would be -3, -4, and -5. All right, let's take a look at one more. Now again, same input numbers, but the machine, even though we can't see it, something's changed. Okay, so now when I drag in the 1, something different is going to happen to it. We pop in a 1. In this case, it spits out a 2. If I drag in a 2, the machine's going to do its thing. It's going to spit out a 4, input a 3, 8, input a 4, 16. Now again, because we're looking at very particular patterns of what this machine is doing, this one, hopefully you see it, as we go down 1, 2, 3, 4, 5, 6, 7 in our input numbers, notice what's happening to our output numbers. 2, 4, 8, 16. What do you think the next number would be? Well, in this case, 32. How about the next one? Hopefully you're thinking 64. And then this one, 128. All right. So this is the idea of a function machine. It's basically the visual interpretation of what we're trying to do with these linear equations. All right, so we're going to basically do the same thing that the machine was doing on those previous clips. What we're going to do is we're going to treat this equation here, y equals 3x, as our machine. And what we're going to do is we're going to create input numbers, pop them into the machine, and see what it spits out as an output number. All right, now for today's work, the nice thing is you can pick whatever numbers you like. So let's say, for example, off the top of my head, I pick 4. All right, so my input number is 4. I'm inputting it in for x. So here, for my calculations, what I'm going to do is I'm going to do 3 times 4, which is 12. And so 12 is my output number for y. Now, what we want to do here, though, is we're looking for a pattern. So what we need is more data. So I might pick another one. Now, again, I can just pick at random. I'm going to say 1. So if I plug in the 1, the machine does its work. 3 times 1, which is 3. And then, even though we are going to be talking about what are called linear functions, I'm going to do at least one more point. And I'd like to see that on your work as well, where you're plugging in at least 3 input values and getting out 3 output values. And my recommendation is that, I know most people will probably stick to positive numbers because they're easier, but for one of the numbers, pick a negative. Let's say -2. All right, so we plug in 3 times -2. We do the work, and our function machine spits out a -6. And we do the negative just to make sure we're getting a complete picture, some on the positive side of the graph, some on the negative side for when we do actually graph these. But for now, we're just focused on the data table. All right, let's try one more like that. Let's put another example in our notes. Let's make a data table for this one. Now, once again, for the input, you get to pick. So let's say I pick 2. So the 2 goes into this input for x. And so we do our calculations here. -2 times 2 plus 5. Now, of course, we have to remember our order of operations, which is -2 times 2 is -4. And then -4 plus 5, that's 1. So an input of 2 gives us an output of 1. Pick another number. In fact, a good number to pick often, 0. So if we plug it in, -2 times 0 plus 5, well, that's going to equal 0 plus 5, which is equal to just 5. And like I said earlier, try to pick at least one negative. We want a complete picture. We don't just want positive numbers, but we want negatives as well. So let's try -3. -2, input -3 plus 5. To order of operations, we get -2 times -3 is 6. And 6 plus 5 is 11. All right, so input a 2, out spits out a 1. Input 0, we get a 5. And -3, we get an 11. All right, so this is the idea of taking an equation and pulling out the data of what this equation represents.